I still busy on chapter 3, and chapter 3 is about the set. We are understanding, we are trying to understand about sets. Okay? And hope that by tomorrow we will complete the chapter. So then next week we start chapter 4 about binary operations. Okay? Okay, so if you have any questions, please feel free to come. It's 01 0210. Yeah. Office 0210. I mean office 0210. Second floor. At department. Building 7. Okay? So if you have any question, you can email me and then ask my availability when you want to talk. And then we will get yeah. So building 7, second floor, office 0 to 10. If you have any problem. Alright. So last time we spoke about sets. Okay? Different type of sets. That is not a subset of real numbers. Okay? We try to look at different sets. A different set which is not a subset of R. Okay? And we give some examples. For example, if I take the set of tuple, if I give it, I take the set of tuple x1 element of R squared. This is already a set that is not a subset of R, such that maybe I have a condition x is equal to y. We saw that this is actually a subset of R squared. Yeah. So, if you want to represent this this set, you should represent this in a Cartesian plan, x, y. So you find out that this set actually is a line. It's a line, okay? And we also saw another type of set, which is a set of polynomial. Polynomial of degree 2. Okay? And we saw another type of set, which is the set of matrices. Okay? So if I tell you this, A, B, C, A, such that B equal to C equal to 0. So this is a set of matrices. Okay, so the element of this set is not a tuple. It's not a polynomial, but it's what? It's matrix. So if I ask you to give me an element of this set now, you should not be giving me a tuple. You should not be giving me a polynomial, because the elements of the set should be of the form of the general form. Okay? It should be of the general form. How the set has been characterized. Okay? So if I look at this is the set of matrix I explained to you. I think in semester 2, you will see linear algebra matrix. So they will explain to you in detail what is a matrix. They will explain to you how to add matrices, how to multiply. Okay. So but here now we just want to give you an introduction, just because we want to give you an example. Okay. So here now I told you that the matrix is a table. So here it is a 2 by 2 matrices. Okay? This is 2 by 2 matrices. We call it 2 by 2 matrices. It has 2 columns and two row and 2 columns. Okay? Okay, so yeah. An element of this set. If I give you an example, my question is 111 element element of my set B? That's the question I'm asking. Is one more element of my set B? Hmm? No. Why? Yeah, correct. Because B and C are not zero. So that's simply mean that actually this one is an element. Yeah? And if I maybe modify, it is an element. Yeah. So you will see the form of the element of B already. But I will try now to change actually the characterization of B. I will try to change the bit now. I could say if I change it, you see, so you know what the condition you need to verify, right? Yeah? Okay. So now we want to see how we can prove that a set is a subset of another. Okay? So given a set B, another set AB, I said that this set is a subset of B if every element of A can be found in B. That's what we defined earlier. Every element of A can be found in B. Yeah? Okay? But then in your notes, if I said, let's consider that as a C and D, I do like this. I think the notation is here. Yeah. Okay, so this notation, it simply means that actually C is not a subset of D. Okay? C is not a subset of D. So if I wrote like this, so this simply means that actually there exists at least one element in C that is not in D. That's actually the meaning. At least. So if I can find an element of C that is not in D, that simply means that actually C is not a subset of D. Okay? So that's the meaning. Okay? So let me give an example. If I consider my C, which is 1, 2, 5, and my D is 2, 7 minus 3, 1, 4. The question is C a subset of D? Is C a subset of D? Yeah. Is C a subset of D? No. Why? Why no? Because 5 is not. Yeah. You just find at least one element. At least one. So, but actually, you don't look at if you see 2. 2 is in C, and 2 is in D. Yeah. 1 is in C, 1 is in D. But there exists at least one element in C that is not in D. If you can find at least one element of C that is not in D, then simply it is not a subset. And that's what you say. So since 5 is not in D, then C is not a subset of D. You understand? You understand how to prove that? A subset is not. A set is not a subset of that. But if you want to prove that a set is a subset of D, then this is every element of A has to be is in P. Yeah? So this every. But here, at least one element of C, at least one element, at least is not a B. See now the difference, how to prove, so if you want to prove the subset, you need to actually look at every element of A and then find out that all elements of A that are identical, they can be found in B. But here now, if you prove it is not a subset, you need to just exhibit one element, and that's all. Okay? Good. Okay, so this is better now. Okay, let's look at few example. Okay, we look at the example in the notes. Example 3.20. So this example, we have actually the set P, which is x, y, such that s greater than 0 and y greater than 0. And then we have the set Q, which is such that x, y greater than 0. Okay? So, if we want to show something, look at those two sets. They are actually a set of R square, because it's stubborn. If I ask you to give me an element of P now, you should not be telling me 1. Or you should not be telling me 3. Because 3 is not an element of P. Can you give me an example of P? An element of P? Yeah. 3, 4. 3, 4. Okay. It's a tuple. Yeah. A couple. So 3, 4 is an element of P. You see, the way it is, the way that the set has been characterized, then you could try to see the way that the set is characterized, and then give what the element look like. So here now is a couple, it's tuple, okay? 3, 4. Why? Because actually it's a set of tuple so that x and y are positive. So minus 1, 1 is not an element. Okay? Minus 1, 1 is not an element. Okay. Yeah. So can you give me an example of element of Q? Huh?
0.
Sorry?
0 and 0.
Who is it? Minus 2 and minus 2. Are you okay with it? Okay. Yeah, correct. Yes?
Yes.
You have any objection?
No.
Okay. That's good. Okay. Now, we want to show that this set P is a subset of Q. What does it mean? I want to show, let's show that P is a subset of Q. So as I said to you, if you want to show a statement like this, you need to take all the elements, every element of P, and then you need to show that those elements are also in Q. Okay? So you should not be exhibiting an example. You should now use an arbitrary element. So an arbitrary element. So let x, y be an element of P. Okay? So in general. So let x, y be an element of P. Okay? So what does it mean for x, y to be an element of P? simply means that S has to be positive and then Y has to be positive. Right? Okay? So that simply means, can you close the door? What did I tell you don't close? Yeah, so that's this mean that uh, imply that x is greater than 0 and y is greater than 0. That's the meaning. For an arbitrary element x, y to be in P, that simply means that s has to be positive, and then y has to be positive. Yes, sir? Okay? But we want to find out if this element is in Q. So for this element to be in Q, what we need to check is that if actually x and y, the product is positive. That's what we need to check. Okay? So if I have x positive and y positive, when I do the product, what will I get? Positive, right? Yeah, so since x is positive and y is positive, then actually the product should be also positive. Yeah, for sure. The product should be positive. Yeah. So what's the implication now is that this element is in Q. That simply means that x, y is in Q. Do you understand? Yeah. Sorry? Yeah. This step now, the last. Okay. So you agree with me the previous step, right? Okay, now look at the set Q very well. The set Q, the way it's defined, is a set of double, right? X and Y, such that what's the condition? X multiplied by Y greater or equal, eh? If you do like this, it's greater or. Okay? So that simply means that we have x, y greater than 0 or s1 equal to 0. Yeah? Or. So if I want to look at any elements that look like that is in Q, I just need to find out if I have one of these conditions satisfied. But we just prove that actually this xy here is greater than 0. Because I assume an element in P. An element in P, the condition is that S has to be greater than 0 and Y has to be greater than 0. So when I do the product of two positive numbers, I should still get positive number. Then it has to be in Q. Good? Okay. Alright. So then, conclusion, I can conclude that A is a subset of Q. That's what I can conclude now. Yeah, I can conclude that. Good. Now let's show that Q is not a subset of P. So if I want to show that Q is not a subset of Q, what should I do? Yeah.
Make it so that the answer is 0.
Which
is 0.
Sorry?
X, y equals 0.
Mm-hmm.
Okay. Then you can.
Yeah. So okay. So pick an example. You say x, y, 0.
Yes, 5. Yeah.
Like this.
Yeah.
Okay? So x and y is not the 0, 0 is it in Q?
Yes.
Yes.
And is it in P?
No.
That's correct. That's a good number. You see that? So it says x, y is 0. So that's the 0, 0 here actually isn't Q. Yes? But 0, 0 is not in P. Yeah, that's a good example. You understand? At the back. You understand? Can you give me another example? If you understand, can you give me another example? No, at the back. Yes, you.
Make x plus minus 1 and y minus
Minus 1, minus 2. Yeah, correct. It's work. Good. That's something you understand. Okay. So you just pick one example. You don't have to pick 2, 3. You don't have to. Yeah.
So how many marks is this?
Sorry?
How many marks do they weigh?
What do you mean?
I mean, this type of questions. How many marks do they weigh?
I cannot answer now. Depending on the test that you have. I mean, this question, I don't know how to answer.
If they say 4 plus divide.
Huh?
If they say 4 marks plus divide.
4 mark for what? For what? For which proof?
This one.
Which one? Which one? Which are you talking about? This one or this?
Both of them.
Okay, no, so don't focus your attention on math. Actually, it's something that I avoid when I'm studying. I don't focus my attention on math. I just need to understand what is going on. Okay? So I will come to answer, but you just need to proper understanding of the lecture notes and the thing. So actually, if you understand correctly, you should not be discussing about math. Okay? Yeah? So it's obvious that if you understand the notes, if you understand the class, what we are doing in class, for sure you have a good mark. Huh? Yes, that's the implication. If you understand what is going on in class, all your lecture and do your exercise, it's obvious that you have a good mark. So you don't actually need to focus your attention on how many marks it is to take. But okay, let me come back to your question. So depending actually on the number of exercise that is on the question sheet, and depending on the number of questions that is in question sheet. So then we split the mark. Okay, so I cannot tell you that actually we allocate this mark with this kind of question. Okay, so but now, yeah, maybe there could be, maybe this is a question, and I ask you, show that P is a subset of Q. This I could allocate maybe 2 marks. Okay, and then next I will ask you, show that Q is not a subset of P. I could also allocate you 2 marks. Okay. Just, yeah. So I cannot tell you that we fix this kind of mark for such kind of question. It could be 1-1 or it could be 3-3 here. But at the end, it doesn't matter. So if I ask you, I say, okay, this is 2. It's over 2. Yeah? So I can look at your step actually. If you pick a random element and then you show that it's greater than 0, yeah, I will give you maybe 0.5 or 1. Yeah, yeah. Yeah, yeah, you can put it in words. You can put it in words. You can use words. Yeah. So, but there's what we call mathematical writing. I'm not so sure if it is your curriculum. I'm not so sure. Yeah, mathematical writing. So actually, this course is immediately after logic. But I see that it's not. So how to write mathematics? Yeah. So there is a proper way to write math. So you could choose words to write the math. Yeah. You could also choose symbol, but you could also mix the two. Yeah. That's fine. That's also fine. Yeah. So you could say now that okay, let's consider x, y. I could do like let's consider s, y, b an element, but this is an element of b. Okay? So x and y is an element of b, meaning that x is positive and y is positive. And therefore, x, the product, x and y should be greater than 0. Conclusion, x1 is in Q. That's all. Okay? Yeah. Where are we? Okay, so the person that asked about math is satisfied of my answer. Okay. Good. Okay, let me take another example. We have the sets of matrices. Let's consider A to be A, B, C, D, such that A, B, C, D is different of 0. And the set B, which is A, B, C, D. A plus B is equal to C plus D. Okay? So those are the two sets. So we want to show that. Okay. We want to show that B is not a subset. So let's show that actually B is not a subset of A. Okay? So that's what we want to show. But if you look very well, you see that AB are matrices, right? Are matrices. Okay? And can you give me an example of an element of A? Sorry? Yeah, give an example. If you say, okay, let me repeat his answer. No, let me repeat his answer. And I say an example of A. You say anything about 1. Is it an element? Huh? Anything about 0. Is it an element? Huh? It's an element. No. It's not an element. Yeah? You see anything about 0. 2 is about 0. 2 is an element of A. Yes. I'm asking you. 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 Is 2 an element of A? Huh?
I can see that you're looking at me.
Yes, but I'm asking you. You respond to my question. Is The element of A are matrices. Yeah. The element of A, look at A very well, is matrix. Yeah, 2, 2, 2, 2. Yeah, 2, 2, 2, 2. So actually, what you're saying is 2, 2, 2, 2. This is an element. Rewrite it. An element of A. Yeah. So, but you should not say 2. 2 is not an element of A. No? Because the element of A should be necessarily a 2 by 2 matrices. Yeah, it should be 2 by 2 matrices. So when you have a set, look at the set very well, how the set have been characterized. Don't just give an element because you want to give an element. Look at the set, how it has been characterized. And the element should be of the form of the characterization. Yeah. So 1, 1, if you take 1 now, 0. Yeah. It's not. Yeah, it's not. Because A, B, C, D is different of 0, right? But I mean, the way that they wrote it is not so clear in the notes. Yeah, yeah. So in the note, actually, they say A, B, C, D is different of 0. It is not clear. But if they say for all, because what is here, actually, it could be A, B, C. One of them could be different of 0. So you have to be careful the way that the thing is stated. So if I have a kind of statement like this, yeah. Yes, yes. No. Wait. Okay, I see. So maybe what they mean is that for any ABC and D different of 0. I think that's what they mean in the notes. I think that's yeah. So I mean, let's try to understand this right here. Okay. So what they mean is that for any A, B, C, for any B and C, and D has to be different of 0. Okay. But actually, people will understand this like this. If you say A, B, C, D different of 0, they might think that actually you mean A, B, C, D, all of them to be different of 0. It could be your interpretation. That was your interpretation. Yeah. So that's why I actually I'm just looking at carefully what they mean by writing this in the notes. Sorry? Okay. And this one. Is it in A? Yeah. What do you mean? Is it in A? Is this element of A? Yeah. Yeah, okay. Let's understand it like this way. That actually, what you mean by writing this is that this is for any A, B, C, and D has to be different of 0. Okay? Yeah. So if it is like that, so then it's an element of A. Why? Because we have A, B, C. No, sorry. A, B, C. This is A, B, C. Any. It could be any number. Okay? But especially this has to be different of 0. Okay?
Yes.
Yeah. Okay. Good. So what we want to show? We want to show that B is not a subset of A. So what we need to do is that we need to find an element of B that is not in A. Right? Yes or no? Yes. Okay, who can give me this element? Yeah. Yes, at the back. Come right here. You see what? 40. 40. Okay. It says 0, 0, 0, 0. Okay? So, is 0, 0, 0, 0 element of B? Is 0, 0, 0 element of A? Yeah. Okay. Good. So we have 0, 0, 0 element of B, but 0, 0, 0 is not element of A. Therefore, we don't use it.
So,
Yes.
can you please go back to the first one there, where you say A?
A. Yeah. So
To conclude, are you saying only one should be 0 or
No,
maybe
but-
2 or 3? Yeah,
no, it's D. It's only D that's different of 0.
it's only D.
Yeah. Different of 0. But they all are A, B, C or N. Huh? Then, okay. Yeah. So, yeah.
So why would they write it like that instead of just writing things not conscious?
Can you repeat again?
Would have been wrong to say that the statement existing without the same.
Oh. Yeah, that's a good point. Okay, so yeah, it could be like that. Actually, if it is what we mean, then we can actually rewrite it like that. So for any A, B, C, and D different of 0, I can write it like that. Yeah.
So since it's not different from what they wrote, it's not different from what we got the example.
It's not different to what is in the note. What do you mean?
So I use the question is not the same. So it's interpreting A, B, C, and D should not be the same.
No. If I understand what you are saying correctly, if I don't put A, B, C there, doesn't mean that it is for any A, B, C. It can be any, which can be also 0, 0, 0, 0. Yeah? Okay? But then if I put it the way that I put and the way we wrote it, that simply means that we mean by any A, B, C, which could be 0 or no 0 or maybe 0. Yeah, is it clear or not? Can we come on the board? Oh. Come on the board.
I think he's saying that the way that they wrote it originally, so with A, B, C, D not equal to 0, it should be interpreted the other way. So I think
Oh,
he's
the
saying
other
that's
way.
the question.
Like all of them should be different of 0.
That's what he's saying, that the way they've written it, that's how
Oh,
they
I see. That's what we mean. Okay. Let me. Let's wait a moment. So let's try and let's try what he said. So let's have an eye of what will be done first. So we say A, B, C, N. Okay? And then let's look at it. Yeah. Can we what? Delete that. Okay. Yes. I heard from them. Okay, so yeah. So if actually we mean that all those A, B, C should be different of 0, then if you pick an element, let's pick an element of B, which would be, we should pick something such that we have 0 so somewhere. Okay? Yeah, we should pick something in B so that we have 0 somewhere, such that when we have A plus B equal to C plus D, so let me make 0 here. Yeah, it could be between A, B, C, D, actually. So between A, B, C, D, something has to be different of 0. Yeah, okay? So if I take 0 now, for me to have this is D, and I need to have C plus D. My C should be here, right? My C here. Okay? So let's take 3. So then I will have 1, 2. Okay? Yeah. So this element here actually is in B. But 1, 3, 2, 0 is not in A. Do you understand? Why is not in A? Because we have D, which is equal to 0. Yeah. Okay, so it could be like we have 0 here. Okay? And we need to have maybe I have 4 here, then I have 2, 2. Okay? Actually 0, 4, 2, 2 is
B.
Yeah, I said A. We mean that by writing this, we mean that A, B, C, D, all of them has to be different of 0. Okay? All of them. So this element here is in B. Why? Because if you do the summation, 0 plus 4 is equal to 4, and 2 plus 2 is equal to 4. But then this element is not in B. Why? Because A is equal to 0. Okay? Yeah. Okay. Okay. So then, let maybe if you want to be aligned with the notes, if I write this, that simply means that all of them has to be different of 0. Okay? Yeah. So then I could distort the question. For what we just answered here, what we answer here actually, let's modify a bit. We consider my set A prime, which is the set of A, B, C, D, such that D is different of 0. Okay? And my set B prime, which is the set of matrices A, B, C, D, such that A plus B is equal to C plus D. Okay? So, and we answer that this element is in A prime, okay? And this is in B prime, but this it there?
It's talking, it's talking.
Yeah. We still have